All right, let's look at some system applications. So it says set up and solve a system of linear equations to answer each of the following. Okay, the first thing you're going to want to do is identify your variables. You can use any variables that you want, but do whatever. Okay, so it says the sum of two numbers is 95. One number is 17 more than the other. What are the numbers? Okay, well, we've got two numbers. So let x equal the first number, let y equal the second number. Okay, and then I'm going to have to look for clues in the problem to see, all right, well, what do I do with this? Okay, so it says here that the sum of two numbers is 95. That means that x plus y is equal to 95. Okay, one number is 17 more than the other. So one number is 17 more than the other. Now, and it doesn't matter which one you do this, which way you do this. Okay, so here I have a system where I have one variable solve for itself. So I'm going to take this and replace it for y. So that gives me x. I'm sorry, replace it for x. Whoops, I almost made a big mistake there. So I have y plus 17 plus y is equal to 95. So 2y plus 17 is equal to 95. 2y then becomes 78, and y is equal to 39. Okay, so there's that. Now I'm going to take this equation along with this, and this tells me that x is equal, instead of y, 39 plus 17, which tells me that x is 56. Okay, so the numbers are um, 39 and 56. Okay, let's see. Derek invested $10,000 but split between two different accounts. The first one pays 5% annual interest and the second pays 8% annual interest. If Derek earned $710 in interest at the end of the first year, how much did he invest in each account? Okay, so this is one, anytime you have an interest equation like this, you're going to set up two equations. All right, so the first, I'm going to let x equal the amount at 5% and y equal the amount at 8%. Okay, so I'm going to set up a table now. Okay, so I'm going to have a column here for each interest rate, the 5%, the 8%, and then the total. So one of my equations is going to be the amount posited. Well, we don't know that. So that's x and that's y, and the total is $10,000. Now I'm going to have an equation for the interest. Well, 5% of the amount deposited here, so this is 0.05x. 8% of the amount deposited here, 0.08x. And the total is 710. So you've got your two equations here. You have x plus y is equal to 10,000, 0.05x plus 0.08, I'm sorry, and that's a y, excuse me, is equal to 710. So you've got your system here. Now what I want to do, let's see, they're all lined up. You can use substitution or elimination. It doesn't make any difference here. I prefer elimination in this kind of problem. And what that means is I'm going to take this equation, I'll eliminate the x, so I'm going to multiply times negative 0.05. So this equation now becomes negative 0.05x minus 0.08y is equal to negative 500. Okay, so if I look at these two equations together and add them up, I'm going to, this is 0.05. What's wrong with me? Okay, so this is going to be eliminated. This gives me 0.03y is equal to 210. Divide by 0.03, and I get that y is equal to 7,000. Okay, then I'll go back to this equation, and this tells me x plus y, but I'll put in the 7,000, is equal to 10,000, which tells me that x is 3,000. Okay, and if you want to write that out, let's see. Who is this Derek? Derek invested, let's see, what is x? 3,000 at 5% and 7,000 at 8%. Okay, John's motorboat took 4 hours to make a trip downstream with a 5-mile-per-hour current. The return trip against the same current took 6 hours. Find the speed of the boat in still water. Okay. All right. So I know I'm going to set up a rate, time, distance table. And let's see. We're looking at downstream. So downstream, the time is 4 hours with a 5-mile-per-hour current. Well, what they want to do is find the speed of the boat in still water. So let R equal the rate of the boat in still water. So this is going to be R plus the current. So downstream is plus the current. Okay, then the return trip against the current took 6 hours. So the time is 6. This is upstream. And he's going against the current, so he's going to take the speed of the boat and subtract 5. And the distance is just the distance. So we'll make d equal the distance. We don't know what it is. It doesn't matter. What we do know is that these are the same. So I know that on my downstream, if I multiply r plus 5 times 4, that's going to equal my distance. So distance is equal to r plus 5, and I'll put it over here, 4 times r plus 5. For my second one here, I know that the distance is equal to 6 times r minus 5. Well, the distances are the same, so I just set these two equations equal to each other. So I have 4 times r plus 5 is equal to 6 times r minus 5. So this gives me 4r plus 20 is equal to 6r minus 30. So I'll subtract 4r from both sides, so that gives me 20 is equal to 2r minus 30. Add 30. 2r is equal to 50. Divide by 2, and I get r is 25. Okay. And that's all it asks. It doesn't ask what the distance is, but we can figure that out. So the speed of the boat in still water is 25 miles per hour. Okay, so let's see. We're going to make t-shirts. All right, so store sells plain sweatshirts for $19.95 each and Coca-Cola sweatshirts for $29.50 each. In one day, it sells 120 sweatshirts for a total of 200 or $2,833.30. How many of each kind were sold? How many of each kind were sold? So that tells me what I'm going to identify my variables. So let P equal the number of plain sweatshirts and C equal the number of Coke sweatshirts. Okay, once again, I'm going to set up a table. You don't have to necessarily. Okay, so I'm going to deal with, I've got, let's see what I've got here. Okay, so I'm going to have one column with the number of shirts. So the number of sweatshirts. So we don't know how many. So for the plane and for the Coke and the total. So P plus C is equal to 120. Then the revenue. Well, each plane, so I have 1995P, and each Coca-Cola, oops, I'm sorry, 2950C is equal to 2833.30. Okay, now again, you can do this any way you want. Um, I so I know that P plus C is equal to 120. This plus this is equal to the total amount. I like doing these by elimination, but again, you don't have to. But I'm going to multiply this entire equation by negative 1995. So that gives me negative 1995p minus 1995c is equal to negative $2,394. Okay, so when I add these two together, this is eliminated. 2950 minus 1995 is 955c. And when I add these together, that gives me 439.30. When I divide, I get C is equal to 46. Okay, so then I'm going to combine that with my top equation here, and I know that P plus 46 is equal to 120. When I subtract 46, I get P is equal to 74. Okay, so there were 74 plain and 46 Coca-Cola shirts sold. Okay, an airplane flies 3,000 miles with a tailwind of 5 with a tailwind in 5 hours. The 3,000-mile return trip against the wind took 5 hours. Find the speed of the plane and the speed of the wind. Okay, so let's let P equal the speed of the plane and W be the speed of the wind. So now I've just got your basic rate, time, distance problem. Okay, so what do we know? We know it's a 3,000-mile trip. So 3,000 goes in both of these. Okay, so what we don't know is with the wind and against the wind. So the rate is the plane plus the wind. here, this is the plane minus the wind. And this took 5 hours, and this took 5 hours. Okay, so I know I've got my two equations here. This times this equals this, and this times this equals this. Okay, so my equations are 5 times P plus W is equal to 3,000. And then my other equation is 5 times P minus W is also equal to 3,000. Okay, so I can take each of these and I can divide by 5. So this equation becomes P plus W, whoops, is 600. I do the same thing here. I can divide by 5. I should have left more room here. Sorry about that. And this equation becomes P minus W is equal to 600. Okay, well this is actually set up for elimination. So that gives me 2P, this is eliminated, is equal to 1200. So P is equal to 600. Okay, so I can use either one of these equations along with this, so I know P, which is 600, plus W equals 600, which tells you the speed of the wind is 0. Now that actually makes sense. If going against the wind and going with the wind, they take the same amount of time, that means there's no wind. Okay, so the speed of the plane is 600, and it doesn't say, but we'll call it miles per hour. And the wind speed is 0. Okay, so this is a good place to stop.